Rolling motion is a difficult concept to understand. In today's video, we are going to learn rolling motion with animations and solve two amazing problems. And there is a surprise for you in the end, so hold on. I am Saino Prem, IIT Madras graduate from Sharp.Education, and let's get started. What are we going to cover in this video? First, we will learn what is pure rolling and define what is translation velocity and rotational velocity. We will be covering the other types called forward and backward slipping. Then we will get into the energy part and discuss translational kinetic energy and rotational kinetic energy. Then we will review spring and gravitational potential energy, which will help us solve the problems, and finally we will solve the problems. What is pure rolling? It is a combination of translational motion and rotational motion. Hereafter, we will take translation terms in green and rotation terms in orange. The sphere is in translation motion on a smooth surface where all the points in the body are having the same velocity v. In this case, any random point p on the sphere will also have the same velocity. In case of rotational motion of the same sphere about its center, the points have different velocities given by the multiplication of r, the distance of the point from the center of rotation, and the angular velocity omega. Now the random point P is having velocity r omega, where small r is the distance from the center. If we combine these two, we get a motion like this. If v is equal to r omega, it is called pure rolling. What about friction? In this scenario of pure rolling of a sphere on a flat plane, you don't need any friction. Once the sphere is rolling, it will continue to do so even if the friction coefficient becomes 0. Hence, if the sphere is rolling already, it does not require friction to continue rolling. It can keep rolling even if the surface is smooth. Most wheels of land vehicles undergo rolling. In this example, the wheels of this car are almost in pure rolling. If v is greater than r omega, it's called forward slipping. If v is less than r omega, it's called backward slipping. In this case, the wheels are in backward slipping. Now that we have understood rolling, let's learn kinetic energy in rolling. Since rolling is a combination of translation and rotational motion, the total energy is the sum of translational kinetic energy and rotational kinetic energy. The green color of the sphere denotes the translational kinetic energy, and the orange color of the sphere is the rotational kinetic energy. I will explain why the green area is greater than the orange area in a while. Thus, the total kinetic energy is half mv squared plus half I omega squared. For a sphere, it is half mv squared plus half into 2 by 5 into mr square omega square. Since moment of inertia is 2 by 5 mr square for a sphere. Since v is equal to r omega, we can say that total energy is half mv squared plus 1 by 5 mv square. Since half mv square is greater than 1 by 5 mv square, the translational kinetic energy is greater than the rotational kinetic energy. Hence, green color has a larger area than the orange color. The major point in rotational motion chapter is to consider the translation motion and rotation motion separately. I can't stress this point enough. This single point is enough to solve most of the problems in this chapter. I wish I had known this secret when I was preparing for JEE. Now let's understand this point with this animation. The sphere is rolling on a smooth surface, hits the smooth wall, and only translational kinetic energy is lost. It still has the rotational kinetic energy. Now, if we introduce friction in the floor, then the rotational kinetic energy is lost. It comes to the rest. Therefore, friction is required to make any changes to angular velocity of the rolling body. While solving, analyze translation motion and rotation motion separately. Before solving the problems, we will review spring potential energy and gravitational potential energy, which are required to solve these problems. This sphere in translation motion collides with the spring. No energy is lost. During compression, the translation kinetic energy as green color is converted to the spring potential energy as blue color. During decompression, the stored spring energy is converted back to the kinetic energy of the ball. The spring potential energy is half kx square. We will take potential energy terms in blue hereafter. In this, where k is the spring constant and x is the compression or elongation in the spring, the translation kinetic energy half mv square is converted to the spring potential energy half kx square. Thus, these two must be equal. The gravitation potential energy. The sphere in translation motion starts climbing the curved surface. No energy is lost. The translational kinetic energy is converted to gravitation potential energy of the sphere. The change in color slowly shows the conversion between kinetic energy and potential energy. Gravitation potential energy is mgh, where g is the acceleration due to gravity and h is the maximum height the ball has reached. Thus, half mv square equals mgh. Now, with the concepts learned, let us solve these problems. First question. A sphere of mass m and radius r rolls without slipping, that is pure rolling, on a horizontal smooth surface. It collides with a light spring of stiffness k with a kinetic energy half mv squared plus 1 by 5 mv squared. Find the maximum compression of the spring. As we know, there is no friction or energy loss to stop the rotation. The sphere keeps rotating. So nothing happens to the rotational kinetic energy, but the translation kinetic energy is converted to spring potential energy during compression. Thus, half mv square is equal to half kx square, and the maximum compression is v into root m by k. Second question. A sphere of mass m and radius r rolls without slipping, that is pure rolling on a horizontal smooth surface. It climbs up a smooth surface where the maximum height reached by the sphere. As we know, there is no friction or energy loss to stop the rotation. The sphere keeps rotating. So nothing happens to the rotational kinetic energy, but the translation kinetic energy is converted to gravitation potential energy. Thus, half mv square is equal to mgh, and the maximum height is v squared by 2g. Hope you understood these concepts. Let us know in the comments which topics of JEE Physics you want us to cover in our next video. The surprise is that there are one-to-one mentoring sessions with me and my IIT friends, and also there are free online questions for practice with animations. Use the link in the description for registering. Please support us by liking and sharing our videos, and don't forget to subscribe to our channel.